Number of mole over volume. Number of mole over volume times molar mass. So what is number of mole over volume? So mass concentration is equals to number of mole over volume is the same as molarity multiplied by what's this one? Molar mass. So one important equation that we have learned here is that mass conc equals to molarity times molar mass. So you keep this in your notes, that mass conc is molarity times molar mass. You always need this, and this can be used to convert mass conc to molarity and molarity back to mass concentration.
No,
okay, equals to molarity times molar mass. So mass conc is molarity times molar mass. So the formula that you need to put in your head right now is that number of mole is mass over molar mass. Number of mole is volume over molar volume. Number of mole is number of particles over number of Avogadro. And number of mole is equal to concentration times volume. Then finally, you need to remember the meaning of mass conc, the meaning of molarity, and you need to know the relationship between the two of them. That mass concentration equals to molarity times molar mass. So you can see that I lay emphasis on this particular equation, mass conc, molarity, because these are the key questions that we expect in every exam. So this, how many equations have we written now? 1, 2, 3, 4, then 5. Very important. The other are just concentration, the mass conc and the molarity. So last year question, we're going to look at the last year question now. I expect you all to have the question with you. So while we read the question, I'm going to solve it. Then I will post the question on your WhatsApp group, so anybody can join. So you can check the question before you watch the video, or you can just have the question written down somewhere while you are watching the video, in order for you to have a better understanding of the whole story. So let's start with the question, please. So you can just speak loudly.
Question 1.
Okay, question 1.
A is a solution of triisonitrate 5 acid.
Now you can see they said A is a solution of triosonitrate 5 acid. That's HNO3.
B is a solution containing 6.90 gram of potassium triisocarbonate.
B is a solution
containing 6.90 gram.
Containing
6.90 gram of
6.90 gram of
potassium triosocarbonate 4 per dm cube.
Potassium triosocarbonate 4. Okay?
Per dm cube.
Okay, per dm cube. Now you can see, let's quickly look at the analysis of these two guys. They told us about A. They said A is a solution of HNO3, meaning that A is a solution which is acid. While B is a solution, and what is in B? Yeah, what is in B? They said in B there are 6.90 gram, and we have put it in 1 dm cube. That's the meaning. If I'm giving you 6.9 egg per egg, that means every one egg will contain that. So I have 1 dm cube of water, and I pour 6.9 gram of K2CO2 and K2CO3 potassium carbonate in it. Now from here, what did they do? They put a particular amount inside a volume, mass over volume. They have given me mass concentration of B from this information, so I can get the mass conc of B. If I know the mass conc of B, what do you think? Mass conc, and I know B is K2CO3, so I can calculate the molar mass. I can get molarity of B. So all information about B can be obtained. Why? Because I know the mass concentration of B. Okay, let's continue.
If 25 cm cube of potassium triisocarbonate 4 neutralized to 23.55
if 25 cm cube of K2CO3 neutralizes
23.55 centimeter cube.
23.55 3.55
centimeter cube
of the acid used.
Using meteorite as indicator.
So they use meteorite as the indicator.
Equation of the reaction.
Okay, so the equation of the reaction is
K2CO3
K2CO3
plus 2HNO3
plus 2HNO3
to give 2KNO3
2KNO3
plus CO2
plus CO2
plus
plus H2O. Okay, so this is the equation of the reaction given here. All right.
So calculate the
from figure 1
concentration of solution B in mole per dm cube.
All right. Now, from the information that we have been given about B, do you think it's difficult to calculate the concentration of solution B in mole per dm cube? No. Why? Because I already know the mass and the volume of solution B. So what can I get from that two information? The mass concentration of B. If I know mass concentration is molarity times molar mass. I told you that molarity is also called molar concentration. Molarity is also called concentration in mole per dm cube, right? So if you are looking for this and you know this, then you know molar mass. So the only thing you need to calculate about B right now is the molar mass, and they have given us in the brackets below that K is 39, C is 12, and oxygen is 16. So we have 39 times 2 plus 12 plus 16 times 3, which is 48. I sum it up and get a particular value, and that value is the molar mass. So you will now say molarity equals to mass concentration over molar mass. What is the mass concentration? 6.90 gram per dm cube. So that is answer to the very first question. Okay, so that first question I'm going to solve it here the way I just talked about it. Okay, now that's question 1. We are looking for the molarity of B. So what are we going to say? We say mass conc of B equals to mass over volume, and mass conc of B equals to, what is the mass? 6.90 gram over 1 dm cube. So therefore the mass conc of B is equals to 6.90 gram per dm cube. So if you know the mass conc, what will you now do? Mass conc equals to molarity times molar mass. Okay, so I'll rub this. You can rewind your video in order to reget that again. So now I'm going to calculate the molar mass of B. B is K2CO3. K is 39 multiplied by 2 plus 12 plus 48, because this is 16 times 3. This plus this will give me 60, and 39 twice will give me 78. So therefore I have 78 plus 60, and 0 plus 8. 0 plus 8 is 8. 6 plus 7 is 13. So 138 is the molar mass. So what are we going to have? So we're going to say from here, molarity equals to mass conc over molarity. Mass conc is 6.09 gram per dm cube over 138. I think that will be 0.05 also. 69 times 2 should be this. Okay, yeah, that's 0.05. That's 0.05. So it means that mass conc, molarity equals to mass concentration over molar mass. So molarity, which is C of B, is now equals to, what's the mass conc? 6.09 gram per dm cube over the molar mass is now 138. This is how we calculate it. Okay, so that means CB, which is molarity of B or concentration of B in mole per dm cube, is equals to 0.044. The unit will now be what? Mole
per dm
per dm cube. You know they said we should look for the concentration in mole per dm cube. Alright, so that's what we're going to get for that as for question 1. So that's the final answer for question 1. Why again, when we are looking at question 1, they said we should look for the concentration of B mole per dm cube. But we know mass of B and we know the volume in which they put B, so we get mass conc first. When we know the mass concentration of B, then we calculated the molar mass of B and we use the formula. Mass concentration equals to molarity times molar mass. Then molarity is now equals to mass concentration over molar mass. Concentration of B in mole per dm is now mass concentration of B over molar mass of B. So mass concentration of B in mole per dm is now 0.044 mole per dm cube. So that's the solution to last year question. Okay? So that we are going to the next question like that. Oh, yeah.
Question 2.
Question 2.
Calculate.
So I'll rub this now. Question 2. Calculate the
number of potassium ion in 1.00 dm cube of B.
Okay, so in question 2, calculate the number of what?
Potassium ion.
Okay, of potassium, only potassium.
Yeah.
Of potassium ion in
1.00 dm cube.
In 1.00 dm cube
of
B. Okay. Now, if you look at B very well, you can see that B is actually K2CO3. B is K2CO3. And if you remember that when they ask you to calculate the number of ion, that means the formula they want you to actually use is that number of mole equals to number of particles over number of Avogadro. So if I'm looking for the number of particles, I am going to say that the number of mole should be equals to number of particles over number of Avogadro. But you can see that they told me the volume that I'm going to work with, and because they have given me the volume that I'm working with, we have to remember that number of mole is also equals to volume. Okay, the number of mole equals to concentration times volume, right? So you remember that number of mole is also equals to concentration times volume, and I've been given volume, and I have calculated the concentration before. But because it's only potassium that I want to deal with, how can we get the concentration of the potassium here? You know, this is the concentration of the OB, and the OB is K2CO3. So let's calculate the concentration of the potassium inside, potassium ion. Oh yeah, let's ionize K2CO3. How do we ionize it? K plus CO3 2 minus, right? But how many K do we have here? We have 2. So that means that whatever concentration we have here, look at what is here is 1, what is here is 2, and what is also here is 1. So whatever concentration we have here, we have twice here, we have twice here. So the concentration of potassium ion here in this 0.004, this one is 0.044, right? This one is 0.044, right? Mole per dm cube. Why this one is now times 2, so which is going to be 0.088 mole per dm cube. Let me use the advanced symbol, molar, big M, because of space. So why this one will also be, this third one will also be 0.044 molar. You should know why. Because it's only potassium ion that I'm looking for. So I have to look for what's the concentration of everybody, 0.044. Oh yeah, ionize it. This is the potassium ion inside, and this is the molarity. But what is the volume that they told me? They said in 1 dm cube. Look at it. Calculate the number of potassium ion in 1.00 dm cube of B. So that means that the volume of B I have is 1 dm cube. Why the molarity of the potassium ion is this? So what is going to happen? We automatically going to use this concentration multiplied by the volume, right? And we get the number of mole. So that's what I'm going to do here. So from what I have here now, can I say that the number of mole equals to, okay, equals to, what's the concentration? 0.088 multiplied by, what's the volume? 1 dm cube. So therefore, the number of mole here is going to be 0.088 moles. And if I know number of mole and I know number of Avogadro, can I know the number of particles? Yes. Why? Number of particles equals to number of mole equals to number of particles over number of Avogadro. I have gotten the number of mole. So what will you do? You put 0.088 equals to number of particles over number of Avogadro. And they gave us number of Avogadro already in the question, right?
Yes.
That's
6.02 times 10 raised to the power 23.
So your correct answer is now this multiplied by this. So 6.02 times 10 raised to the power 23 times this is the number of potassium ion in 1 dm cube of B. So that's the answer to the second question. So, and I believe we can rub that. So you can just go back again to look at the solution if you have any confusion. And you can ask me on the general WhatsApp group created. Okay, so let's go for the next question now. That's question 3. 1, 2, 3.
Calculate the concentration of solution A in mole per dm cube.
Calculate the concentration of solution A in mole per dm cube. Now, do you remember that we know nothing about A other than the volume that we titrated C? If 25 cm cube of this neutralizes 20 kilograms of the acid used, right? Now, from here, what can you see? You can see that clearly that this is the volume of the acid, this is the volume of the base. We have already calculated molarity of the base, you remember, but molarity of the acid, which is Ca, is unknown. That's what we are looking for. From the balance equation, what is the number at the back of the base? Number of mole of base is 1. Number of mole of acid, Na, is equals to 2. Can you see from the balance equation the number at the back? So I can clearly write that. We have acid, base, we have Na is equals to 2, Ca is equals to, I don't know, Va, what do they call it? If 25 of K2 neutralizes this of acid, Abi? So volume of acid is 23.55 cm cube. Then for base, yeah, let's go for the base now. What do we have for the base? Yeah, let's go. Number of mole of the base. What do we have? Number of mole of the base. Nb equals to 1. Cb, concentration of the base. We have calculated that one. I think that was 0.044 mole per dm cube. You still remember? Then what's the volume of the base that they now use now? The volume of the base they use now is 25 cm cube. 25 cm cube. So which formula is going to help us here? We're going to remember that CAVA over CBVB equals to NA over NB. Yes. Okay, so we have CAVA over CBVB equals to NA over NB. So try to get all your marks. There is one mark by making what you are looking for the subject of the formula. So since I am looking for my CA is what we are looking for. So we are cross multiply. Everybody like CA, we are cross multiply. What do we have? CA, right? You know these two guys will be disturbing him. So you will later use it to divide everything. They are equals to everything here. What's everything here? NA, CB, VB over who and who is disturbing CA? That's VA and B. So we only substitute into that equation and our answer will come out. So if you don't mind, I will rub that up again because of space. So CAVA over CBVB equals to NA over NB. That's what we are using to get the answer. So therefore, CA will now be equals to, what is NA? According to the write out we did the other time. 2 multiplied by, what's CB? 0.044 times what's VB? I think they use 25 divided by what's VA? 20. I can't remember. Please let me to check that question. I wrote it here now by Robbie. I think 23 point something. Maybe 23.35 and 25 points.
23.55.
Alright, 23.55 times. What about the number of mole of BNB? 1. So CA is now equals to, so you now press calculator. Please let me to punch this. That's 50. That's like great. That would be 2.2 or 0.22. This up. 2 times 0.044 times 25.
That's 2.2.
Okay, that's 2.2 divided by 23.55. That would be 0.0. Okay, so CB now
0.09.
is equals to 0.09. Do you sorry, CA new. CA is now equals to 0.09 mole per dm cube. Mole per dm cube. So that's the CA that we are looking for. Position of A in mole per dm cube. But question here. Okay.
Question 4.
Question 4.
Calculate the volume of CO2
Okay.
that will be produced at STP.
Okay. Now look at, we are looking for the volume of this one, Abby. Unknown. Right?
Yes.
That's the volume we are looking for. But do you know that I already know information about these two guys? And because I know information about any of them, I can get a number of mole of everybody. For example, the information I know about this guy, number of mole equals to CV. Do I know the concentration of K to CO3? Yes. That was 0.044. You remember? 0.044 times, what about its volume? They use 25 cm cube. So please help me to press, 25 cm cube over 1000. I must use dm cube. Why? Because this condition is mole per dm cube. So the volume too must be in dm cube. That's the reason. Is that clear to everyone? So the number of mole is now 25, 0.044 times 25, everything over 1000.
That's 0.0011.
0.0011 mole. That's number of mole. Now, what's the number at the back here? 1. The number here is 2. So once I know the number of mole of this, the number of mole of here will be times 2. The number of mole of here will also be whatever is here times 2. But look at what is here, 1. What is also for CO2? 1. Whatever mole here is also the mole here. Now that I know the number of mole of the CO2 to be equal, number of mole here is also that of CO2. So which is 0.0011 mole, right? So once I know that one, what will happen? I am looking for volume, I know number of mole. How? I am going to say number of mole equals to volume over molar volume. The question already gave us molar volume at STP. So number of mole equals to volume over molar volume. Number of mole equals to, the volume that you are looking for equals to number of mole times molar volume. So the volume is now, what's the number of mole? 0.0011 times the molar volume at STP is now 22.4 dm cube. So the volume of CO2 produced is now 0.024 okay dm cube, like that. I mean 25 dm cube. So that's the volume of that one. Is that the question? Okay, so that's all to number 1. So we're going to do number 2 next time and post for you guys to watch. Thank you. Okay, so I think we're going to do that, but